So what we're going to do today is the lab with springs and pendulums. And to be straightforward with you, this is the second time I'm doing this. We're going to put up the best video. Might be the second, might be the first. We're going to do springs for certain, and I'm going to decide how much of the pendulum thing I want to do. I think I'll do all of it, but you should be able to do the pendulum thing almost completely by yourself. Anyway, so for the springs, this is our usual spring. It's what's called a zero length or an extension spring, which means I have to stretch it. This is about 7.5 centimeters long when there's no forces acting on it. All right, I'll hold it in one spot, not stretch it. That's how long it is. But I can change its length. You can see that it changes. And the more force I apply to it, the greater the stretch. Or the more I want to stretch it, the more I have to pull on it. Now, normally in the lab you'd have versions of these and you would stretch them out. What I find is this one, which happens to be the one I had, doesn't work. It's not going to give you enough data. So what we're going to do is rubber bands. And we've laced them. If you ever laced rubber bands together, it's actually kind of fun. You get a big string of these. Certainly people do that. Is you get a big rubber band, you lace it together, now you have a rubber band tied together. We're going to use 3 of them. That's going to give us enough stretch. Now, I don't know the answer to this, but there's our rubber bands. I don't know if there's a particular spring constant for this. I've never done it with these particular rubber bands in this configuration. But what we're going to do is say that the end of the hook is our 0 point. So we're going to look, we have our science box, and our science box needs to wake up, and we're going to set it to where when there's absolutely no force on the spring, so the rubber band's slack, I want to 0 it. And then we're going to stretch until we just see that there's some force, and then let it go back till it's 0, and then we're going to set the ruler. So the point of all that is you're going to be able to see the number as we measure it. Now, what this is going to mean is I got to move this thing 70 centimeters at least. So I have to move the camera as we do the measurements. But you're going to be able to see the number, and you're going to be able to see the position of the ruler along the of the spring of the rubber band along the ruler. And we're going to hold the ruler down in place so that we're measuring when there's 0 force. All right, there we go. So I'm going to start by stretching it one. So right now it's 0. The force you should see is 0. You're not going to calculate a spring constant from that. But what you're going to do is take data points and calculate the change in distance and the change in the force and use that. So in this chart, as you fill it in, this is asking you to calculate as you go. So you can either take a pair like 9 and 18 and calculate the spring constant using those two, or you can go from 1 and 18 and calculate between those. There's a lot of different combinations. That's okay, because on the back, what you're going to do is plot the force versus the displacement. And that'll give you a straight line, hopefully. We're going to see. So I got my cables out of the way. We're going to stretch it now. So this is just, you're going to write data down. What I'm going to do is review the data and write it down as I watch the video again. So this is stretching at 1 centimeter. Now the camera is going to give you a little bit of perspective weirdness. All right. So I'll try to put it to where it's the view I got. But, you're going to have to do this. If you did this in the lab, you'd have the same problems. So there's 1. Oh, by the way, you should always stretch out your rubber bands as you're doing this, because what we find is you don't get the same force. Anyway, so we're getting our 0 point. All right, now here's 1 centimeter. And it's within the margin of error. Now here's 2. And what you'll notice is that between 1 and 2, the force that we needed doubled. It's kind of what we expected. All right, so here's 3. And it tripled. Hey, this might actually be linear. So we're not going to go 1, 2, 3, 4. We're going to expand the distance between points. And it's not regular, because data is never regular. So we're going to get 5. That has promise. Now we're going to get 9. Okay, that's good. Now I got to get to 18, and that means I need to move the camera a little bit. So now we have 18. You can see 1.31 there. Wake up, stay awake. Now after 18 is 26, I'm going to move it again. And we have 1.62, 1.63, kind of your choice. What I'm realizing is I'm kind of getting my wires and cameras and stuff tangled up. And we're going to go to 32. We have 1.78. Sorry, it's 34. We have 2.03. Okay. So after 34 is 42. You can see as I moved it, there is a perspective change. You kind of have to be right over the number. So there's 42. 2.32. Now we'll go to 50. And 50 here is 2.67. Now we're going to go to 58. I'm going to move down. So 58 is here. 2.92, 2.95. Now we go to 64. 3.21. And then we go to 70. 3.57. All right, that's it. That's the data. So we'll review this. This is a shorter video than the other one. And whatever the best one is the one that you'll see. Now, what we're going to do is do this in parts. This is the spring part, and then we're going to do the pendulum part second. It's going to be a separate video. All right, so just be aware of that.